screen. You still see full screen, right?
Yeah, that's correct.
Okay. Okay, so yeah, my name is Ana Gomez, and I'm from IKERLAN. I will first of all make a very short introduction about what IDEAS is, so that we understand what we are talking about. So IDEAS stands for AI-driven industrial equipment product lifecycle, boosting agility, sustainability, and resilience. In the IDEAS project, our purpose is to develop AI technologies for supporting the entire life cycle. That means the design, manufacturing, use, and all the reuse, repair, and recycle. So the whole life cycle of industrial equipment as a strategic instrument to improve sustainability, agility, and resilience of the European machinery manufacturing companies, such as PAMA, that we'll be later talking about this. So we actually have 4 different suites referring to the design of the industrial equipment, the manufacturing, the use, and the repair, reuse, recycle. We have different solutions in each of the suite. Actually, today we are going to talk about the fabrication optimizer, the condition evaluator, and then the prescriptive maintenance and the smart retrofitter. We have all these 4 solutions, and there is also this machine passport that aims to gather the information from all the previous solutions and all the suites, so that we can know how a machine has been designed, it has been manufactured, how it has been used, so that we can later have decisions on how to recycle some parts or how to reuse some parts, to know if we can do that or not, to know how the design parameters affect in how the machine is being used, if they have an actual effect on the machine use, etc. So I will talk about all the solutions, or some of the solutions that IKERLAN is developing. So just a small introduction about what IKERLAN is. We are located here in the north of Spain. We are a private, non-for-profit technology center created in 1974. So we are now 50 years old. We are in our anniversary this year. We are within the Mondragon Corporation and also a member of the Basque Research and Technology Alliance. And we are a reference center in permanent transformation of the technological needs of the products and services of the industry. So just some numbers, we are more than 400 people right now. We collaborate with international technology centers and universities through different collaborations, as this European project, for example, but also some other means. And we have 3 areas of expertise: digital technologies and artificial intelligence. That is the one, it's not the only one, but it's the more involved in IDEAS project. Electronic embedded system and cybersecurity, and then also energy and mechatronics. This mechatronic part is also involved in IDEAS in the design suite. So today we are going to talk about 2 different solutions: the condition evaluator and the prescriptive maintenance. The condition evaluator is a toolkit that allows us to determine the condition of the machine as a whole or of some of its components when it is in working conditions in the factory where it is being used. So when the industrial manufacturer designs and manufactures the machine, usually it is in their premises. When it comes to the use phase, usually it goes to the client side. Here we have the example of PAMA, that actually some of the machines they build, they are also used by them. So this is very interesting for us. And the prescriptive maintenance is somehow in between the use and the repair, reuse, recycle, since the aim is to predict the remaining useful life, to be able to identify some maintenance requirements, and to extend the overall machine remaining life. With all of this, what can PAMA or any other industrial manufacturer So it will be a better efficacy during the equipment's production, also a better use of the machine. We will then see some advantages precisely of each of the solutions, and optimize maintenance plans and prediction of the component failure. So to do all this, what have we done? So we have a common part for all the solutions we are working in. This means also the anomaly detector, which will not be presented today, but it actually shares this common part. And in this common part, the main aim is to have a generic, very easily configurable and user-friendly solution. So the common part includes mainly 3 functionalities. The first of them, we can see it here in this part above, and it allows us to define the components of a machine, which variables we can measure, and how they relate to each other. So I can have a part of the machine, and from this, from the motor, for example, I can measure current, speed, torque, whatever parts that I can measure from this component. So here is very easily configurable. We just put the name of the machine, the name of the component, the name of the variable, and then we can associate the components with the variables. This allows us especially to give context to the results that we then obtain, so that if we are seeing a degradation of some component through the condition evaluator, we will see that through some variable or a combination of variables that are associated to some components. So we can say which component is the one that has this behavior. This configuration that we can build here, it can then be saved in a JSON file. And actually, it can also be uploaded later, this JSON file. And actually, we have done this configuration with a basis on some lookup tables that PAMA has provided us from the beginning. So this JSON that they already had can be loaded here, and the actual tree of all the components of the machine and all the variables is created automatically. So you don't have to fill in all the information, because actually in PAMA's case, we are talking about more than 200 variables. So if we have to put this by hand, it will be quite hard and time consuming. But actually, since we already had this JSON file, you can just upload it and everything is created for you. Another thing that can be done is to load files, CSV or XLX files for the moment, Excel files. So this will be just to have them available for use inside the solution. And the last thing that we can do in this common part is to configure a MongoDB connection. Actually, I think this is a very common approach, and in PAMA, all the data that they are gathering, it's in some MongoDB databases. So here you can just connect to the database and extract all the information from this MongoDB collection that we have inside there. So as you can see, well, then all the data, when you load some files or you configure a MongoDB connection, you have some functionalities to see the data that you have uploaded there. Both in table or in graph mode. And as I said before, this allows us to give context to the obtained results, but also to personalize very much the application. So for example, if I connect to PAMA's database, all the names that I will see from the variables, etc., will be in the language that they have created them, or and they will see exactly the component name that they want to see, the variables as they are used to have them. Because if you do something that supposes that the variable needs to have some name or whatever, it will not be very personalizable later on. So with this part, we personalize to the specific needs and give context to the obtained results. So for the condition evaluator, here we have the potential to reshape the current state of condition evaluation in many sectors and industries. It focuses on a repetitive operation and characterizes the behavior, being able to infer the current working condition at machine or component level. Actually, we do this in general variable per variable, and then we can have a general state of the machine. It has a training part and a testing or inference part. So in the training phase, we have some test cycles that we that we consider the normal behavior. We train how this normal behavior is. And then in the inference part, we evaluate how the condition is. So we have some graphs, different graphs. Here we can see a time evolution. So here we can see that in the beginning, it was everything green, and it has been evolved, and some parts started to not behave properly, so they enter in the orange zone, and afterwards it also appears the red zone somehow. This solution will be very linked also to the prescriptive maintenance that we will talk later, as the prescriptive maintenance aims to give some remaining useful life estimation. Of course, when we are at the first stage of life of a component or of a machine, probably it makes no sense to have a prediction of the remaining useful life. So actually, with the condition evaluator results, we can determine some threshold. So if we start to have a red zone and it is at least 25% of the samples that we have in red condition, we can start predicting the remaining useful life for that component. So what advantages does this have? So it has adaptiveness to the input data. It is very versatile, independent of the sector of the process. It can give us performance improvement as the machine condition is being monitored, and the solution allows to anticipate the undesired scenarios, and also increase productivity. So optimizing production planning and maintenance activities, especially when used together with the prescriptive maintenance. So this one provides an estimation of the remaining useful life, which actually remains a challenge for all equipment manufacturers due to its complexity and uncertainty. And it provides critical information needed to improve any maintenance, retrofitting, or second life strategy. The interface is quite similar. We again have a training and then a testing part. Actually, here to train, when we have these monitored signals, we need to train having data until failure. For the moment, what we have done is we don't have data until real failure, so we have synthetic data that has been generated, but with the basis of what we have. Also for the condition evaluator, we have some good condition, and we have generated data for later times, and to see this evolution. So here we have also all the methods that you can select. You can parameterize them. Of course, to parameterize and to choose the method, some knowledge needs to be acquired, or needs to the operator, or in this case, maybe it's a data scientist that first has to train a model. But then the use of the inference part is very easy, and it will be possible to use it by any operator with no knowledge. Here we have an estimation in different time steps of the remaining useful life with some normal distribution, because this is not a very certain estimation. So we give some interval in which it can move. Some advantages: it can be implemented in existing production value chain with an existing data monitoring system with minor configurations. It assesses the risk of failure and predicts its remaining life to deploy more intelligent maintenance strategies. So giving optimized equipment performance, allowing proactive maintenance strategy with consequent cost savings. And then it also enables optimizing production planning and minimization of spare parts inventory. If you know when a part will need to be replaced, you can in advance have this, but not have too much if that part is will not be needed to be changed proximally. And from our part, this would be it. I think now UNIVPM will be presented their solutions, and then PAMA will be saying how they are using or how they plan to use all these solutions.
PAMA company. So as you can see here, I summarize more or less the main info regarding our university. Our university is located in the center of Italy, in the Ancona city, and we have more or less 70,000 students enrolled. Our university is a research and teaching university. In terms of research point of view, here you can find a lot of project, European Horizon, Erasmus, Interreg project that we are enrolling with, and then many spin-off and startup created in the last 5 years. Okay, so we can move to the next slide. Thank you, Matteo. Well, the research group involved in IDEAS project is Industrial System Engineering Group, research group. This group is made up of 16 members, more or less all engineering, ICT engineering, mechanical, environmental engineering. And in particular, our research group is mainly divided into two areas of research interest. The first one regards the digital transition, that regards topics like Logistics 4.0, big data and IoT development for operation management mainly, and predictive maintenance and so on. The second area of our scientific interest regards more the Green Deal topics, such as risk assessment model, sustainable manufacturing, and in particular here we develop life cycle assessment studies, LCC, social LCA studies, and so on. Moreover, we sometimes create agreement with private company in order to disseminate and exploit our research activities. So after this short presentation, we can move directly to the solutions that we are developing specifically for PAMA into IDEAS projects. So I leave the floor to Matteo in order to present the first solutions.
Good morning, I'm Ilaria, and today I will present the solution, the Smart Retrofit solution. The Smart Retrofit is a toolkit that wants to bring an old machine closer to the Industry 4.0 world in order to reach all the benefits that the Industry 4.0 introduced in the industrial sector. So with this toolkit, we can understand the behavior of the machine. In particular, we want to obtain the data from the machine, and we want to reprocess them to obtain value-added information. We can also create a model of our system, and with this model we can simulate different situations for the machine. The Smart Retrofit toolkit provide also an hardware part that is modular and generic, and we can choose the specific sensor according to the scope that we want to reach after the application of the Smart Retrofit toolkit and after an analysis of the machine. Next slide, please. So we developed with PAMA this Smart Retrofit toolkit, and we have an hardware part, a software part, and a communication part. For the hardware part, we have studied different configuration of device to sensorize the machine in a non-invasive way, and PAMA already realized, as we can see in the figure. And then we developed the software part. The software part is composed by several artificial intelligence algorithms. In particular, we realized several decision tree, a random forest algorithm, to monitor and control the machine, but also simulate new conditions. We work also with the communication part. So the hardware part send this data to a MongoDB, and then with API calls, we can obtain the data and reprocess them with the algorithm. And then we can save also the information on the MongoDB. We develop also the user interface, as you can see in the picture. And if you want, I can share a kind of demo, or I can also present at the end of this presentation. As you... Ok, posso condividere? Since there is no direct connection with the MongoDB, actually, currently. So with this user interface, we can see the data in real time. We can also stop the visualization, save this data on an Excel file, and also save this information on a MongoDB. We can also access to the stored information. Also, in this case, we have synthetic information. There are no data, real data. And we have also realized this kind of simulator where we can choose a specific variable, and then we can put manually all the information, or we can upload a CSV file. Okay. And once we send data, we can see the variable predicted and also all the information that we upload with the CSV file. And that's all for this.
Use of artificial intelligence. In the case of implementation at PAMA company, the tool aims to optimize a single production process that is the most critical in the production path in order to avoid the remanufacturing step. The tool mainly predict correction parameter to be passed as input to a 3-axis CNC machine. That machine the headstock of the boring machine slides that can change from 1,500 millimeters to 8,500 millimeters, depending on the model to be manufacturing. The solution is structured mainly the backend consists of 2 artificial neural networks that receive as input 4 groups of measurement and the boundary condition of the component, and return the correction factors for each column point. The user interface was realized in React, which communicates with backend via microservices using the Flask library in Python. In addition, there is the possibility of generate an Excel report of the processing that will be saved on a Nextcloud driver. It's possible to access to the solution. You can still see the screen. Okay. After the login, the solution is really easy and intuitive to use. That's because the main scope is that the solution must be used by the operators. So we put our effort also to try to simplify the user interface. Clicking on Start New Measurement, here the operator can input different characteristics of the component. For example, the job name, the order, the test number carried out, the operator name, date, hour, temperature. Choose the length of the component. Now to speed up the presentation, I just pre-fill it. And clicking on Generate Results, we will generate on the right part the correction parameters related to the 4th set of measurement that concern the component. Here, after a couple of seconds, it's possible to see the results right here. And also the graph regarding the previous measurement that helps the operator and manager to better understand and control the process. If, for example, I report a non-compliant part, and also below I report more useful information. And it's possible also to visualize the report in an Nextcloud driver. Here, for example, a few seconds ago, this is one of the reports. And that's basically all for our part. Thank you so much. Now let's stop sharing the screen and give the floor to Fabrizio.
Great. So good morning, everyone. I'm Fabricio, the R&D manager in PAMA. Now I'm going to give you a brief presentation about PAMA, our role in the AIDEAS project, and finally some hints about the applications of IDEAS solutions in PAMA. So PAMA is a company specialized in the design, development, and manufacturing of milling and boring machine from medium to large dimensions. It is always tricky to explain what machine tools are to non-engineers, but they are basically machine-making machines. They shape parts, highly precise parts, by removing materials, as you can see in this video. PAMA is an Italian company recently acquired by the Japanese Nidec Group. Our headquarters is located in Rovereto, in the northern part of Italy, close to the Lake of Garda. And we have 2 more production plants close to Brescia and in China. The most of our production is exported overseas, especially in Asia and all over the Europe. And we cover a strategic role in the European industry. Indeed, our machines are needed in strategic sectors such as energy, aerospace, and defense. And we cover also other sectors such as earth-moving, naval, railway, general machining sectors, and so on. Our strengths are, first of all, the modular design of our machine, which enables a high level of customization, keeping high the quality and reliability of our manufacturing system. Moreover, as previously mentioned, we manufacture large and precise structures in-house by using our own machine. And here you can deeply understand what machine-making machine means. They are somehow replicating themselves. And having this manufacturing department, we can integrate and test R&D projects directly in-house in a relevant industrial environment. And that's what we are doing also with the AIDEAS solution. So now our role in AIDEAS project, and generally the role of pilots in European projects, is firstly to provide requirements and use cases to solution providers in order to drive the development closer to industrial needs. Then we implement the developed solutions into demonstrators, into prototypes in an industrial environment in order to test them and monitor key performance indicators so that we can provide useful feedback and lessons learned in order to improve step by step the solutions. We decided to be part of the AIDEAS consortium because after the Industry 4.0 programs, we have a large amount of data sets in our hard disk that are useless if we are not able to extract information from that in order to take data-driven decisions. There are different strategies to extract these informations, and AI is one of these strategies, and it is suitable, especially when we have large data sets with many different features and let's say correlations among these data are not straightforward to be identified. AI competencies, as you may know, are few within companies, so we need the support of some of the best research centers and universities from all over Europe. So AIDEAS for us is first of all a way to better understand the potential to boost the sustainability in the industry. When I'm talking about sustainability, I mean the 3 phases. So environmental and humans, which are extremely important, but also economical, which is the key factor to have a successful industry. AIDEAS was chosen also because it covers all the life cycle, as we have seen. Indeed, we have solutions that cover the design, manufacturing, use, and the end-of-life phases of the life cycles. As you can see from this table, which represent the 16 solution of AIDEAS, we are testing and integrating the most of them. Today, we are focusing our attention to 4 of them: the Fabrication Optimizer, from which we expect a better efficacy during large and precise structure machining; the Condition Evaluator and Prescriptive Maintenance, which aims to optimize maintenance plans, also by predicting the component failure; and finally, the Smart Retrofitter, which aims to be applied on old machine in order to extend the life cycle by analyzing and predicting the energy consumption. So how we are applying these solutions in our company? Starting from the Condition Evaluator and Prescriptive Maintenance, you may know that large, complex systems such as our machine tools are failing sometimes. There is something that breaks up. So the most important part isn't to have a machine that doesn't break up, but to be able to plan each maintenance activity without overdoing them. In our headquarters, we have many PAMA machine, 8, which are gathering hundreds of relevant signals from sensors, which sometimes are placed some testing machine on close to critical components, such as pull screw, such as the spindle bearings, some pumps of hydraulic systems. And we're gathering from all the machine data from the numeric control and from other sensors acquired by the PLC of the machine. Anna said that the condition evaluator works in repetitive condition. So we are labeling automatically data that belongs to a set of conditions which are repetitive in time. For instance, a free motion of an axis or a free rotation of the spindle at the maximum speed. So we are able to map the evolution of these signals during the time. These data sets enable the training of AI algorithm to supervise the critical components, and the condition evaluator warns about unusual behavior of signals. We have a link between each signals and the components, so that once we have a warning, we can instruct, we can say to the maintenance personnel to focus the attention on a specific part of the machine in order to understand if there is really something that is going wrong, or if it is a false alarm. While the prescriptive maintenance aims the estimation of the time left to the failure. In this case, we need some failure to train this kind of algorithm. So, which are, let's say, rare. They doesn't happen very often. So up to now, we have to use synthetic data to try to perform some estimation. And we need more time, more years in order to provide good estimations. Take into account that the life cycle of a machine like this Vertiram is from 20 to 30 years. So we can train something very useful. So the key benefits are, of course, the reduction of unexpected failure of maintenance components, which means a precise planning of maintenance activities. Going on with the fabrication optimizer, we have especially one critical operation during our manufacturing process, which is the machining of the guides over which the headstock runs up and down on our horizontal boring machine speed run. In particular, parallelism, planarity, strictness, tolerances are extremely challenging. We need to perform a loop cycle of finishing operation, checking the actual strictness, parallelism, to compute compensation table in order to correct the path of the tool on the machine and see whether the final accuracy is enough to go on with the production or not. We're removing small amounts of materials, the 10, 45 that we have seen in the table of Matteo before, are micrometers. We're talking literally of nothing, removing. And by doing that, we're not able to compute straightforward a compensation table. So we need up to 7 reworking in the less lucky case in order to achieve the correct tolerances. This means that we provide the data of quality check over the last 2 years of column machined, which means around 50, 60 components in order to train neural networks. And the benefits we have seen is that from the preliminary test, we have shown a significant reduction of reworking, and we expect that around 90% of components may respect the strict tolerances in just one reworking, which is something that we know we can achieve and will be extremely impacting for our company, because each reworking takes around 10 hours of this huge machine.
Mm-hmm.
Last but not least, the smart retrofitter. We know that sustainability is a key for the future, is one of the objective of one of the challenge of the industry 5.0. And the smart retrofitter work in this direction. Indeed, it aims the extension of the life cycle of old machine by optimizing the energy consumption. This is nothing than a hardware part that we can see in this picture, which is an industrial edge to store and compute data, and acquisition boards and sensors to acquire energy consumption data from the field. And this is something that can be installed quite easily, even from non-machine builder. Moreover, on this edge computer, industrial edge, AI algorithm must run in order to estimate the energy consumption for a given set of parameters, a given set of working condition. The benefits we expect from this application, which is under development, is the possibility to work by working on a plant level, on a workshop level, to estimate in advance the energy consumption of the whole plant. By doing that, we can change production parameters, such as the feed, basically the feed of the machine, in order to balance the energy consumption and avoid undesirable peaks of current absorption, and reduce in this way at least the cost of the energy. Moreover, we see another possibility quite relevant. So once we know the normal absorption of the various group we are monitoring, which means the estimation. And we are measuring also the actual value. We can compare and understand whether some groups are absorbing more than normal, and use that as something similar to a condition evaluator, something similar to understand whether there's something wrong in an electrical device and subsystem of the machine. So in this brief presentation, we have seen our role in AIDEAS and why we want to be part of this consortium, and we are proud to be part of this consortium. We have seen benefits of the Fabrication Optimizer, Condition Evaluator, Prescriptive Maintenance, and Smart Retrofitter toolkits, and the expectation for who wants to integrate this solution. So I thank you all for your attention, and I would be pleased to answer any questions you may have. Thank you so much.
Thank you so much, Fabrizio, for your presentation.
Going on, because we don't care about what the variables are. They do have this knowledge, and through the information that our solutions can give them, they can learn much more about it. So, yeah, I would just point out that.
Yes, regarding the Fabrication Optimizer, I think that the main benefit is the reduction of processing time, so an increase of the takt time, which in the case of large machine, such as the case of PAMA, it translates into a considerable reduction in the production time, especially in the cost of the production processes. Like Fabrizio said before, every machining step, it requires 10 hours of working, and so they are processes that are costly in terms of money and also time. So I think that the solution can be a good tool that help the companies to better control the process, the internal process, thanks to a data-driven approach.
Okay. Yeah, no, definitely. I mean, obviously, we're talking about big numbers here, right? I think like all of us know that that these things take time and money, obviously, and it's very costly. And obviously, AIDEAS is here to help, right? To try to make these solutions so that they are less costly and take less time. And well, obviously, any help can help. Correct. All right. I don't know if anybody else has any more questions regarding this. If not, I would like to tell you that all these solutions you can have early access. I know we have some participants that are here that represent SMEs. So you can have early access to these solutions. Right now we have the Early Adopters Program open, okay? I can share this link here, but the idea is that you can apply to get early access to these solutions, okay? All of them, all of the ones that were presented and the ones that weren't presented, okay? I can share here my screen, and if I can present here in the Q&A, sorry about that. Yes, in the chat for everybody to see. So this is a link, all right? You may see in our LinkedIn and our social media, we have just extended the deadline for you to apply, okay? This is until the 30th of June, so you can still have time to apply for all of these solutions. And yes, if you do, we expect you to have your application in the meantime, okay? And if there are any questions regarding this, the speakers have presented their emails and so on. I hope you have taken note. But if not, you can go to the page, to the event page, and you can find their social media and also their emails there, and you can contact them directly. All right. Thank you so much. Thank you so much to the speakers, to the attendees. And I think we can close this for today. Thank you so much, and have a wonderful day. Thank you.
Thank you. Bye.
Bye-bye.
Thank you.
Bye bye.